Well, hey there, kiddos. Today we are going to talk about when it's best to use which method to solve a system of equations, because we've learned three now. We've talked about substitution, elimination, and graphing, and we're going to talk about which method is best to use and when, because sometimes, just depending on the system that you have and how it looks, one method might be better than the other, and you could, by all means, use any three of the methods all the time. You could always use substitution to solve a system of equations, or you can always use graphing. It doesn't matter. But depending on how the problem is presented to you, one method might be better than the other. So we're going to talk about when to know which method is best and you know why it's the best one to use in that situation. And then you're going to practice this tomorrow when you come to class. You'll be able to choose whichever method you want, solve the problems in any way you choose. You have the back page of your notes in your packet. It's actually a foldable. I tried to staple it in there so you could just fold it in your notes as is and leave it that way, but I'm not sure I was successful. So if you want to, you can just tear that page off. It folds in half and then you cut on the flaps, and it looks a lot like what I have here. If you don't want to make it a foldable, by all means, you do not have to. You can just take notes on it as is. So substitution is the first one we're going to talk about, and when we do substitution, the best time to use that method is whenever you have a variable already isolated. So you already have a variable isolated or by itself. You already have something that says x equals or y equals, and so it makes it easy to substitute. So the best time to use it if a variable is already isolated, like in this example, which you should write down on your notes. And then we're going to practice solving that using substitution really quick. So if you'll notice, I already have a variable isolated. This y is by itself. And I'm told that y equals 2x minus 10. So in this top equation, I'm going to replace y with 2x minus 10 and leave everything else the same. So I'm going to have to do the distributive property. So I have 4x minus 6x plus 30. Those two negatives make a plus, equals 24. So I will combine my like terms. That's going to make negative 2x plus 30 equals 24. And I'm going to have to subtract 30 from both sides, which leaves me with negative 2x equals negative 6. Then when I divide both sides by negative 2, I get that x equals 3. So now I have my answer. I need to plug it back into one of these to get y. I'm going to use that bottom equation because it's the one that already says y equals. So y is equal to 2 times 3 minus 10, and 2 times 3 is 6, and 6 minus 10 is negative 4. So there's my answer, and so as an ordered pair, my solution is 3 comma negative 4. And the reason, again, substitution was best here is because I already had a variable that was isolated or by itself. So now let's talk about elimination. The best time to use elimination is whenever a variable already eliminates it, will eliminate itself. It's also best to use when the equation, when the x and y are on the same side of the equal sign. So if x and y are already together on the same side of the equal sign, then elimination is probably going to be the easiest because you don't have a variable isolated, and even if something doesn't eliminate already, it makes it easy to set up to do that. So look at the example that we have. You will see that on both equations I have x and y on the same side of the equal sign. Now a variable does not automatically eliminate, but if you look at this bottom equation, I can easily turn this y into a negative 3y. All I have to do is multiply this equation by negative 3. So my top equation stayed the same, and my bottom equation multiplied by negative 3 becomes negative 12x minus 3y equals negative 9. And so I can add these up. That becomes negative 5x equals negative 10, and so x equals 2. Now I take this and substitute back into either one of these equations to find y. I'm going to use the bottom one. So I have 4 times 2 plus y equals 3. And so I have 8 plus y equals 3. And when I subtract 8 from both sides, I get that y equals 5. So my ordered pair solution for this is 2, 5. And so the reason I chose elimination for this one is because both equations had x and y together on the same side of the equal sign, made it easy to multiply by something and eliminate. Now graphing is the last one. Graphing is the easiest, and graphing is easiest to use. The best time to use graphing is when both equations are given to you in this form. When both equations are already in slope-intercept form, so they both are already y equals mx plus b format, then graphing is the best thing to use. That is not the only time you can do graphing, but that's certainly the easiest, quickest time to do it. So this one is already set up. You see both equations are in slope-intercept form, and since I'm going to use graphing to solve, that means I'm going to need my calculator. So let me pull that up really quick. Thought it was starting. I apologize for the pause. Okay, so I have my calculator up, and according to my problem I have over here, I have y equals 2/3 x minus 1 and y equals negative x minus 4. So I'm going to use my calculator. I'm going to go to y equals, and in this first equation, I'm going to put 2/3 x minus 1. So I'm going to do 2 divided by 3 x minus 1. And then the bottom equation was negative x minus 4. So I'm going to do negative x minus 4. And then I will graph them so I can look at and see what it looks like. So I'll have it draw the two lines on the calculator for me. And I want to find where they intersect. So I'm going to press second trace, option 5 for intersection, and then I'm going to hit enter 3 times. 1, 2, 3. So my intersection for those two lines is at that point, negative 1.8 and negative 2.2. So my solution to this is negative 1.8 comma negative 2.2. So that's when I would use graphing. Is if the equations are already in slope-intercept form, it's very easy for me to just plug into my calculator and do it. And so there are the methods. Substitution is best when you already have a variable isolated or by itself. Elimination is best when x and y are both on the same side of the equal sign and you can easily eliminate something. And graphing is best when your equations are already in slope-intercept form. Is that the only time you can use those methods? Absolutely not. If substitution is your favorite and you want to do it all the time, by all means, substitute every time you see a problem. It really doesn't matter. As long as you're using one of those methods and you're using it correctly, you should be able to get to the solution. So we'll practice some more tomorrow. I will see you then. Have a good rest of your evening.